Okay, so this one here was I don't know why this happens, my so-called theoretical one. And it can work with with any of them. So we need to insert, give me a minute. Okay, so if we have to be a little clever here, because this is more than just one. This is the LC. This is actually an RC, and this is an RL, if you think about it, right? So we really should. These headings were for experimental. Or, the device under test. But at the end of the day, they're RL and RC, and this is RLC. Although we did use our standard there, yes. And here is actually an RR. Oh, okay. Yeah, I think so. Yeah, we have to, well, let's get this out of the way. Of course, oh, wait a minute. Better? Well, it's better. Is it good enough? That'd help a little bit. Oh, yeah, I can help a little bit more here. There we go. Okay. Now, we can also go a little further. We should include that in this case, this is a low pass. Because remember, the device under test is Z2. Now, we don't know this yet, but this is now going to be a high pass because inductors go in the opposite direction. Ooh, I hit enter. I hit enter. Low pass. And this is a series RLC. Because we need to get more sophisticated. I'm sorry? RL what? Thank you. Wow, I tell you what, that was like a aphasia. I swear to God, I thought I was typing HI. Because I was talking at the same time. But, I don't know, Bruce Willis, he just had a poor guy. When you get up there, well, I'm 65 now, but I suppose early onset dementia, well, you may not agree with me, but I still think I got my marbles. But in any event, so we, let's see, what's next? Okay, so this was our theory one, and you guys will have data as well. Let's see, what's the best way to do this? This one here was, so I just left it there. I don't have any data, so it's not as much fun to play with that one. Now, what we can do is, you can copy this one, and so for now, let's see how you might want to separate this out into RC low pass or high pass, right? Because this has got a lot of, it's not as useful. I would rather have separate tabs for each type, right? So my suggestion then is to move or copy. And we're going to move to the end, I think, create a copy. And then we're going to rename this one as RC low pass. And I think we can just basically nuke all this, because we don't need the resonant frequency anymore. We might want the 3 dB point. And we don't need the inductor. So we would like the F 3 dB, and it's equal to 1 divided by 2 times pi, 1 over 2 pi times R. So which one of these is, it's the R experimental, right? Sorry? Even more. Oh, yeah, I see it. Okay. I see it. Let me just finish this for a minute. In fact, I'll make the font the same size as the other ones, as the one below it. How's that? Is that better, or should I make it even more? Yeah, I'm going to make it even better if I can. All right, so we're not using, no, we are our standard, right? That's the one we are using. So this is the one we need for the RC circuit, right? So that we don't want to make a mistake and delete the wrong one. All right. So then I said this is equal to 1 divided by, open parentheses, 2 times pi times R. Doesn't matter the order really. I need the F4 key to get the dollar signs. And times the capacitance in farads. Close my parentheses. Okay, so that's 15. The 3 dB point is at 15K hertz.
Can you go back to the previous one? Yeah.
Sure. It's just the one, well, I want to see the targets too, don't I? So 1 over 2 pi RC. Yeah, 1 microfarad. So for a low pass, that's not very good, right? 15K will pass through it. But we can play with that. And let's just check and see that we didn't do anything stupid. We had a 0 in there, and that makes it 100 nanofarads, and the frequency got smaller, the frequency went up. If I make the denominator small, yes. Okay, something's bothering me. 1 over 2 pi RC, right? Maybe I got that wrong. We should look back on our notes. Let's see. 1 over 2 pi RC. Well, we'll make the Bodhi plot, and that'll also tell us something. Okay. So now, oops, escape. This is going to be V out over V in and in dBs. I mean, strictly speaking, you're supposed to put units, right? So this is in ohms, and then this one, yeah, ohm, volts. All right, so remember, oops. Let's remember our formula. Equals minus 20 log, and we pick log 10. Well, you can't pick it. It's so stupid. It shows you those, but you can't choose them. You have to keep typing. Log 10 of V out over V in. I don't know why it's not showing colors. So let me see if I made it. It says I made a mistake, huh? Oh, okay, I see. You have to tell it that it's got to multiply. Now there's colors. Okay. And this one should be about 0, close enough for government work, right? Let's turn that into a number. See how that works. And we can give it some more decimal places just for fun. Now, I need to zoom out for a sec. View 100%. Now I just take my fill handle, and there we go. So I'm not, we said that, yeah, okay, we don't have anywhere near high enough frequency at the moment. So I'm going to put this back to being a bigger number. So now it's going to be 10 microfarads. Oh, wait a minute. No, now I went the wrong way. I need to get rid of zeros. 1, 2, 3. And that's 1 microfarad. So I get rid of another 0. I got 10 microfarads. And that's 50. Yeah, there we go. Now we can see. It's a little bit brute force, but at least we see that these things rolled off. So you can see where you need to finesse a little bit with the frequencies you're going to use. Sir, formula. Of course. And let's zoom back in. View, zoom to selection. Let's see if it works. Oh, what happened? Oh. You're welcome. Okay, so now we need to make a Bodhi plot. And what happened to, there it is. So this is once again a non-contiguous selection. So now we hold down the control key. Now this is a prediction, so I wouldn't put points, but if it's data, you want the points. and it's okay to draw the line. Now, it doesn't look quite right because you have to remember, and something else went wrong. What happened to this is supposed to be negative. Why isn't it negative? V out over V in. I expect that. And so as it gets smaller and smaller, I expect the logarithm to be a negative number. So is it I have to put it negative 1 times? Okay. V out over V in, right? Did I do that right? D7 over E7. This is weird. Okay, well, we'll fudge it for the time being, and I'll have to figure out what I'm doing wrong. Now, the last bit of the Bodhi plot is that we need to do the logarithm. We could have made a column for that, but I like being able to shift back and forth. So you see how we've got an issue where we haven't been to the left of the 3 dB point. So, oops, I want to make that smaller, not larger. I mean larger, not smaller. Made it larger so the frequency, okay, so, yeah, something's not right. Oh, I know what to do. Let's just go look at ones that worked, right? Here we go. 20 log of J8, V out over no negative sign. Okay, I live with that. I still don't understand. Oh, what's that all about? I got to... What happened to the other one? There it is. Oh, it's the same file, Harry. And so, I want the 3 dB point is at 3, of course. Remember we trimmed this down, right? And so we want to raise that a little bit. So let's make this even back a little smaller. There we go. Now it's starting to make more sense. And so 50, let's put a 50 there. And let's put a 100. And now we can begin to see it. There we go. And now the 3 dB point is 1590. So let's make this 1000. There it is. See how it's shaping up? And let's say 1100. Let's see if that delineates it for us. So we select those two, do the fill handle for a while. Yeah. Maybe this should be 700. And you see the game I'm playing, right? And so it isn't a negative. I wonder, the book, he has it wrong in the book then. But now I have the roll-off point. I probably want a little bit more in that area. Yup. Maybe another one. And you see the Bodhi behavior. So this, say, would be 3,000. Yep, look at that. I got it. I'm back in the game. Question?
Zoom in on like your the C and the capacitance and the resistance values that you were
Oh, up
talking about.
above? Sure. First of all, let me just bring that up. There it is. Okay. View, zoom to selection. See, this is one of those times where I had some prepared slides and then I decided to wing this part and I kind of almost went down in flames. Not quite. I'm lucky that I know what it's supposed to look like. I'm disappointed that he was wrong about the negative 20 times. And it makes sense because once that fraction goes below 0, then its logarithm, it goes negative by itself. I don't have to add a negative in front. I don't know what the hell is the matter with him. Okay, do I need to click on anything? The 3dB point again? That's right. Yeah, here it is. So a general strategy would be once you know your 3dB point, put that in the middle of the column of frequencies and then start going back and forth, up and down from it, right? And see how your graph changes. And then that's a great way to know what frequencies to pick when you take actual data, right? You save yourself time this way. So one strategy I've done in the past is that I literally look at my view. Oh, something is not happy. Okay, escape key. And zoom. Let's try, what are we at now? 250%. Let's try 200. Sometimes I'll actually say, okay, there's my resonant frequency, and I've got a column of numbers, so I could say equals to, and literally just plug that in. And of course, it carried along the format. So a number, and we don't care about the decimal places. And now I've got that there. Now I've already tweaked this one up, right? But let's say I started out and this was 100, 500, and I may say to myself, well, that's still not bad, right? So that one worked, but I've got my resonant frequency, or the 3dB, right about halfway, and I just say, well, I'd like a few more points down below, and I'll make this 100, and you can begin to see how the plot starts looking better and better. And then now you do this with your proposed values, make this plot, and then you have a list of frequencies. And you might even want to try making less of them, right? Maybe I don't need quite so many. So I'm going to say, look, I don't want to do so many. But of course, now I got some other, oh yeah, because it's flip-flopping on itself. But, you get the point, right? If you don't, I'll come over and help you. Now, if you wanted this to be, okay, now, what do you do if you want it to be the opposite? Now, for real data, it always works, right? But now, let's see, we want to turn this into a high-pass filter. So now, move or copy, and move to the end, create a copy. Now, we want to make this RC high pass. And we don't need the little 2. Get rid of that. Okay. So now what we've done is I think we've stuck with a fixed V in. We can do that in the theory part. Remember, in the when you take real data, you always measure both of them, because there's always a chance your circuit will load down your power supply, but that won't. If it does that, it'll affect V out and V in equally. So you always take the ratio, but we don't have to bother here. So in this case now, we need to look at V out, and that's quite a mess. Now, one part of it is, though, that we no longer have the inductor, but I think that it already knows that, yeah? Oh yeah, because we just picked the one with the capacitor. Okay, so now what we need is, this is the voltage across the capacitor on the top, right? The bottom isn't going to change. So all we need is the value of the resistor on top. Right? Because, yeah. So let's make sure we don't screw this up. And that is resistor. Don't forget the dollar signs. No, it didn't work. Function F4. Well, I'm going to just put them in manually. Dollar sign, enter. And we get, hopefully, the opposite. And there it is, this is the high pass filter. Of course, I have to change around the frequencies, right? I'm not showing the plateau very well there, right? And so, of course, you have to do things like change this and double check everything, right? But you see, once you've got it going on, it gets easier and easier to move on to the new one that you need. Okay? So remember now, when this coming, I didn't impose this on you for the past logbook because I realized I hadn't. So week 4, yeah, in principle, we should have had these in week 4, but in week 4 I asked you to at least show me your theoretical, your RLC Bode plots, right? I put that in, I changed the assignment, but you have still some time to hand that in. For week 5, you're going to be describing high pass and low pass and the garbage detector, and you have to make Bode plots for them. I'm not going to require that you show me your theoretical prediction. Maybe once. Just say, look, here's the spreadsheet. It's the one I used before. I added the Bode, the dBs to it. And from now on, I'm using that to predict the range of frequencies you see in my data table, right? You don't have to keep, because in the real world, that's all you'd have to do, okay? So make sure you make a note to yourself for this week's logbook hand-in. You're going to be showing Bode plots for your high pass, low pass, and your garbage detector. Okay, so how long I've been, an hour. Wow, not bad. Let's stop this recording.